Hello, we are going to work on this problem that is that corresponds to module 2.4.3. So if you want to review this material, please go to this module in our textbook. This problem tells you that it's giving you system of equations, but already written as a product of matrices, and it's asking you for the value of this entry, so the value of C, such that this system of equations has infinitely many solutions. So we are going to do the computations, and we're going to arrive to the answer that says that none of these values, there is going to be a value, but it's none of -9, 9, or 4. And I'm going to explain to you why the answer is going to be A. Right. Okay, so we have here our matrices P, J, L, and K, which is going to be Q. And because we are asked to determine the value in row 1, column 3, that means that if, let's see. This is a 3 by 2 matrix, this is a 2 by 2 matrix, and this is a 2 by 3 matrix. So when you do this all together, out of the product of these two, I get a 3 by 2 matrix, and when I multiply times L, I'm going to end up with a 3 by 3 matrix, okay? So it does make sense, because then it makes sense to subtract another 3 by 3 matrix, because 3 by 3 matrices multiply times another 3 by 3 matrix, you get a 3 by 3 matrix. So at the end, I end up with a 3 by 3 matrix. And then that means that the value in row 1, column 3, if I just name each of the entries on my matrix as this, that means that I'm looking for this one. This is my goal. Now, I'm doing all of this because I want to save time doing computations, so I'm going to analyze how do I get this number, and I'm only going to do the computations that I need to arrive to this number. So let's start with this one. Suppose that when I do the multiplication of these two matrices, I get, say, a matrix. So out of this, I get a matrix that I'm going to call B11, B12, B21, B22, and B31, B32. Okay, and then I'm going to multiply that times the matrix L. And that's going to give me some other matrix, and let me just put some generic numbers. So that's going to have, like I said, that's going to be a 3 by 3 matrix, so that's going to be C11, C12, C13, C21, C22, C23, C31, C32, and C33. Now this matrix C, which will correspond to the product of all of these matrices, is the one that I'm going to subtract K cubed. And to arrive to this one, this number A13 will be the result of taking this number, the one that has the same position, C13, minus the number corresponding to K cubed that will be here. So we're going to call that, let's see, D13. I'm going to tell you in a moment how do we compute this one, but let's focus on computing C13. Okay, so how do we compute C13? C13 is going to be computed by multiplying this row with this column. So we have that C13 is going to be B11 times 2 plus 0 times B12. And because it's 0, great, I don't need to compute this number. I just need to focus on computing B11. Okay, how do I do B11? Well, B11, this one right here, comes from the product of P and G, right? So let's do that computation. Can do that here. So if I do P times G, that means that I'm going to have negative 2, 5, 3, 6, 1, 0 times negative 1, negative 4, and negative 2, 5. And again, the only number that I care about here is going to be the one here. So that number, I get it by combining these two. So the number B11 is going to be negative 2 times negative 1 plus 5 times negative 2. So that's negative 2 minus 10, so that's negative 2. No, that's positive. So that's negative 8. Okay. So I have B11, and now that I have B11, I can compute C13. So what I have is that C13 becomes 2 times negative 8 so I have negative 16. So far, what I have is that A13 equals negative 16. And now I'm just going to raise the board and tell you how do I compute this part. So we said that the number that we're trying to compute is going to be C13, which is negative 16. And I'm going to subtract this number D13. So D13 corresponds to K cubed, and yeah, that's going to be a 3 by 3 matrix, just like this. So I copied here D 3 times, so we can work on this. So let's see. What I'm going to do is I'm going to do the multiplication of these two, and the only thing that I care about is, if you see, my goal is to compute D13. D13 is going to be computed out of first multiplying these two, and this is going to give me a 3 by 3 matrix, and then out of this matrix I'm going to take the first row and multiply it times this column, the last column, and that's going to give me D13. So let's do that. So when I do, if I only want to compute the first row here, so I'm going to end up having a bunch of numbers here, and like I said, I just want to focus on the first row. So the first row is by multiplying this times this. So I want to compute 5 times 5 plus negative 5 times 5 times negative 5, this times this, I'm getting confused, 5 times 5, negative 5 times 6, and 0 times 0. And this gives me 25 minus 30, so negative 5. So negative 5 is here. So to compute the number right here in this position, we're going to do this row combined with this column. So it's going to be 5 times negative 5 plus negative 5 times 4 plus 0 again. So negative 25 minus 20 gives me negative 45. And that goes here. Finally, I'm going to compute this number, I'm going to combine this with this. So it's going to be 5 times 0 plus minus 5 times negative 6 and then plus 0. So that gives me negative 3. Okay, so I have this one, and the last thing that I'm going to do is I'm going to multiply it. And again, like I said, the only thing that I care is this last column, so I'm just going to copy that one. And these two are going to give me the last position that I was looking for. So this is going to be negative times 0, and then I'm going to do negative 45 times negative 6, and then minus 30 times negative 2. And that gives me 210. Okay, so D13 is 210, and this minus is this minus that I have here. So altogether, the number A13 that I'm looking for is negative 226. Now, if you go to and look again at your answers, you see that this corresponds to answer B. And that's how you arrive to the solution with the minimal number of computations possible to do this.